Hi there, I'm Mr. Goan, and today we're going to be having a look at the National 5 Application of Mathematics Paper 1 from 2023. Now, this is a scan of the paper as it came out only May of this year on the day of recording, so this isn't the SQA's released PDF of it, but it should be everything that we need it to be, and we can have a look at it now. So, let's get started with question 1. Now remembering that this is a non-calculator paper, so for this paper we don't have access to a calculator, we're going to be working out at each step. So in question 1, Josh earns £9 per hour and works a 30-hour week. His weekly outgoings are £220 a week. He saves all his remaining money, books a holiday costing £566, and he's going to take £800 spending money with him. Calculate the minimum number of weeks it would take for him to save the total amount. Now this is only a 2-mark question, so it should only take us about 3 minutes to solve. So to start with, we need to work out what he earns. So he does a 30-hour week at £9 an hour, giving us a total 3 9s are 27, so 39s are 270. His weekly outgoings are £220, so 270 minus 220 leaves us with £50 left over per week. Now, he saves all the remaining money, so that's what he's saving. And it says he's booking a holiday at £566. He also plans to take £800 spending with him, so we need to figure out how many 50s will make that. So 566, oh, that's a 6, plus 800 gives us 1366. We can then divide that by 50, so if we divide it by 50, that's the same as dividing it by 10, and then dividing it by 5. So if we divide it by 10 first, we get 136.6, and then we're going to divide that by 5 using a step sum. Now I do mine upside down, but that shouldn't be too hard to follow. There are no 5s in 1, there are 2 5s in 13 with 3 remainder. There are 7 5s in 36 with 1 remainder, and there are 3 5s with 1 remainder, and so on. And so what we can see here is 27 point something weeks, dot, dot, dot. So we can say that that rounds up, since this is contextual rounding, at 27 weeks he won't have enough, but at 28 weeks he will. And that gives us our answer. Now, on to question 2, and we have a lorry speedometer. Now, this question is always easier because you have the physical paper in front of you. Now, what to do? A reminder that you should have a ruler and a protractor with you, or at least a protractor. I would recommend a ruler as well, as scale drawing will be coming back into the course after 2023. Now, we're told that the lorry's speed is restricted to a maximum of 56 miles per hour. Use the speedometer to determine this speed in kilometers per hour. So if we start by saying that 56 miles per hour, so here's our miles per hour scale. We'll go all the way around to 50, 50 and 60, so there's 55, here is 56, okay? So we mark on 56, and that actually gets us our first mark. Now, using our ruler, from the center of the dial where the needle would be, we can draw a line going up through the 56, and we can see there that what we have is between 80 and 100. Now, if I make this line a little more see-through, just so we can see it a little easier, you can see then that we're looking at a little bit more than 90. So I would accept there, or I would expect there, with my line nice and neat, that I could say 90 miles an hour for this, okay? Now, or 90 kilometers an hour, sorry. We could say that 56 miles per hour is equal to 90 kilometers per hour. Now, realistically, we could also suggest that that was between 88 or maybe at a push 92 kilometers an hour, just for a little bit of range there, as long as we've got an understanding that 56 on this scale translates to something else on this scale. There is an alternative method to do this, looking at the fact that 100 kilometers an hour is equal to 160 kilometers an hour, and then scaling down appropriately. but it does take a good bit more effort. So, moving on to question 3. Question 3. The crowd at the rugby match is made up of home supporters, away supporters, and neutrals. So 3/7 were home supporters, 2/5 were away supporters, and the remaining were neutral. So calculate the fraction of the crowd that were neutral. So what we can do for this one, we can say that 3/7 plus 2/5 were not neutral. Now to calculate this, make my pen nice and thin here, we need equal denominators. Now the lowest common multiple of 7 and 5 in this case is 35. So we can reach that by saying 7 times 5 is 35. So what we do to the bottom, we have to do to the top. And 5 times 7 is 35. And again, if we do it to the bottom, we have to do it to the top. And so what we end up with here is 15 plus 14 over 35. Since the denominators are the same, I can just say that the whole fraction is over 35. That gives us 29 over 35 are not neutral. But we were asked for neutral, so let's say that neutral, N-E-U-T-R-A-L, neutral then is going to be 35 minus 29 all over 35. What we're saying there is that 35 out of 35 is the entire crowd. So if we take 29 out of 35 away, then we're left with 6 over 35. And that is our fraction of the crowd that are neutral. Make the denominators the same, add together the home and away, subtract that from the total, and what we're left with is our neutral. Now in this case, that doesn't simplify, so we can just leave that how it is. Question 4. Geoffrey shared his savings between his 3 children, Sophie, Ed, and Lucy. The money was shared in the ratio 7 to 2 to 6. Sophie received £3,304. Calculate how much money Geoffrey gave to his 3 children in total. So to begin with, let's lay this out. We know that Sophie to Ed to Lucy is a ratio of 7 to 2 to 6. Now, we know that because the names come in the same order as the numbers of our ratio. So Sophie received 7 parts. And the method that I would use to find this is to say that Sophie's 7 parts totaled £3,304. So 7 parts was 3,304, which means that 1 part is 3,304 divided by 7. There are no 7s in 3, so it moves across. There are 4 7s in 28 with 5 remainder. 49 is 7 7s with 1 remainder, and 14 is 2 7s. So now we know that 1 part is £472. If we add these all together, then 7 plus 2 is 9, plus 6 is 15 parts. So the total is going to be our 472 multiplied, 472 multiplied by 15. Two-step multiplication here. We've got 5 2s are 10, 5 7s are 35, plus 1 is 36, and 5 4s are 20, plus 3 is 23. Into our tens column, and we get a 0 into our tens. 1 2 is 2, 1 7 is 7, and 1 4 is 4. Add together these two values, and we get 0, 8, 10, carry the 1, 7, totaling £7,080. £7,080. On to question 5. Question 5. Eddie runs a stall at the school fundraiser. His game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown. A prize is won if one spinner lands on blue or green and the other spinner lands on an even number. Calculate the probability of not winning a prize. So looking at our table here, or our spinner here, we've got red, blue, red, green, and yellow. We also have the numbers 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay, so you win a prize if the spinner is blue or green and you get an even number. So you win a prize on blue 2 and 4 and green 2 and 4, but you lose with every other combination. Now, this is quite a long-handed way of showing it, but I just want you to see this visually, exactly how this works. What we can see is that there were 5 options for the color and 5 options for the number, and 5 times 5 gives us 25 possible outcomes. Of them, there were 2 blue winners and 2 green winners, which means there were 4 winners. So of 25, 21 of them were losing. So the probability of not winning, our probability of not winning is 21 over 25. Demonstrating here that we've got our 25 options, our 4 winners, and our 21 losers. Question 6. Kenny buys a new fridge. The original price of the fridge was £650. The shop's having a sale with a 20% off the price of all fridges. When Kenny goes to the shop, he finds there's an additional 2.5% off the sale price. And it's important there that it's off the sale price, not off the original. Calculate the price that Kenny pays for the fridge. So, the original was $650, and there's a sale on giving him 20% off. So, let's start off with 20% of 650. The easiest percentage to find to a non-calculator is always 10%. So 10% is 650 divided by 10. So that's 65, which means that 20% is 2 of those. 65 times 2 is £130, which means that the sale price is going to be 650 minus 130, which comes out as £520. Now, our boy Kenny arrives there and finds out he's getting an extra 2.5% off this 520. And so we need to figure out what that is. So again, 10% of 520 is 52, just dividing by 10. 1% is going to be our 10% divided by 10, which is £5.20. 2% is going to be double that, £10.40. And 0.5%, 0.5%, is going to be half of 520. 520 divided by 2. Half of 5 is £2.50. Half of 20 is 10, giving us £2.60. So we can say then that 2.5% must be these two added together, which gives us £13. So he's going to get an additional £13 off. So new price is going to be 520 minus 13, which is £507. Now you've got to be careful with that one, but if you accidentally find 2.5% of the original 650, there are some of the marks that you can still gather from that, from doing the method correctly, even if you start with the wrong number. Now, question 7 is our container packing question, but it's quite different to a lot of the ones you may have done as practice. In practice, we quite often will have the box of biscuits able to be fitted in multiple ways. In the exam this year, they gave us the box of biscuits has to go in this way, since 10 and 10 are the same, but there are two different boxes we can put them in. The lid has to be at the top, so they can only fit one way. So what we can do then is we can say box A. A has dimensions, well, we'll say A, length, breadth, and height. So A's dimensions are 42 by 51 by 50. And since it won't matter which way around we do them, we don't actually have to do more than one organization for this. So dividing 42 by 10, dividing 51 by 10, and dividing 50 by 15, matching the 10, 10, and 15. There's our height and our height, our length and our breadth, our length and our breadth. So when we match this up, we get 4.2, 5.1, and 15, dividing both by 5, we get 10 divided by 3. This is going to be a long one, but we can see then that 15 and 15 is 30, then 45, so we're going to get 3 point something. Now, we can't fit 4 and a bit of a box in, we can only fit 4 in. We can't fit 5 in a bit, we can fit 5 in, and the same for 3 in a bit, we can fit 3 in. With that in mind, 4 times 5 times 3 gives us a total for box A of 60 boxes. Box B we can do in a similar way. Box B is 45 by 72 by 32. So we can see 45 divided by 10 is going to be 4 and a bit. 72 divided by 10 is 7 and a bit. And 32 divided by 15, there are two 15s in 30 and a bit. So our total here, 4 times 7 is 28, and 28 doubled is 56. 4 times 7 times 2. And here we had 4 times 5 times 3. Now, we've now determined the maximum number of tins. Here's our maximum, 60. Now, some notes on this one. If you face a container packing question, if you calculate volume at all, you lose all the marks straight away. This is not a volume question. You can't melt down the boxes of biscuits and just pour them in. You have to fit them in exactly as they are. It does mean you'll have leftover space. So if you calculate the volume, you'll get nothing. Laying out your work like this so that you can see how many you can fit in with the extra ignored will let you multiply these numbers to get your totals in both orientations. So we can fit 60. Justify your answer. Use working to justify your answer, sorry, it means we don't actually have to write like a sentence or anything. Our working is our justification. Oop. So, carrying on. Question 8. Janet traveled by car from her home to a meeting. She arrived at the meeting at 10:15 a.m. She traveled 136 miles at an average speed of 40 miles an hour. She stopped for 50 minutes for breakfast. What time did she leave home? Okay, so firstly we need to know how long she traveled for. And this is our time is distance divided by speed. Our speed distance time equations here. Okay, that leads us then to 136 divided by 40. So simplifying that, we can divide by 10, then divide by 4. So I'll say that dividing by 4, we get 13.6. So let's see how many minutes she was driving for. We've got, or sorry, how many hours she was driving for. That's an important thing. We've got, the 1 moves across. There are 3 4s in 13 with 1 remainder and 4 4s in 16. And that's 3.4 hours. Now we're going to need to turn that 0.4 into minutes. Now we know that there are 60 minutes in an hour, so 0.4 times 60 is the same as 4 times 6, since we times both, divide this by 10 times that by 10, or times by 10 then times by 6, and 4 sixes are 24. So her time traveling is 3 hours, 24 minutes, plus the 50 minutes for breakfast. So what we can do now is we can make a timeline. So I'm going to make a little timeline here. We know that she arrived at 10:15 a.m. If we take 50 minutes off that, jumping back 50 minutes, then we get back here at 9:25. From there we can take 24 minutes at 9:01, and from there jump back 3 hours to 0601 or 6:01 a.m. Now, both of those answers would be accepted, but the 6:01 a.m. is the more correct one, since that's the format that our question was given in. Okay, always try to match the format of your question with your answer. Question 9. Design for a skate park ramp is shown. The height of the ramp is 70 centimeters. To be suitable, the ramp must have a gradient of 0.35 plus or minus 0.01. Determine whether the ramp is suitable. Use working to justify your answer. Now, a quick tip for this one. Anytime you see a tolerance notation, solve the tolerance and state your limits. The maximum is going to be 0.35 plus 0.01, which is 0.36. The minimum is 0.35 minus 0.01, or 0.34. Stating your tolerance whenever you've got a tolerance to work with is normally worth a mark all on its own. Now, as we continue on, we're going to work out the gradient, but to work out the gradient, we need our measurements in the same format. So what we have here is 70 centimeters and 2.1 meters. Now, I find whole numbers easier to work with than decimals, so I'm going to turn my meters into centimeters. Times by 100, and 2 meters becomes 210 centimeters. Sorry, 2.1 meters becomes 210 centimeters. Now, gradient is the height, I can't spell today, our height divided by our length, which is 70 divided by 210. Now we can simplify that. That's 7 over 21, or 1/3. And we know that we can turn 1/3 into a decimal. That's 0.33 recurring, or on forever. And now we can make a comparison. The ramp must have a gradient of 0.35 plus or minus 0.01. Now 0.33 is smaller than our minimum. So we can say, no, it is unsuitable. 0.33 is less than 0.34. And remember, when you're using a less than, the crocodile always eats the bigger number. Num num num. Question 10. Now, this one was a little bit tricky, but mostly because the layout and the transferring. An important thing with a network diagram like this is that you must have the letter and the number for each box. Now notice that D has been done for you. D takes 2 minutes, and we can see here D takes 2 minutes. So that's already been put in for you. Now what we want to do is to find the task that is preceded by nothing. And we can see here that's F. So F doesn't require anything to be done first, and it takes 2 minutes. Now, if we have a look, the ones that require F are A and E. So we know A and E are going either way here, but we need to figure out which way around they go. So if we look at A, once A is done, what things require A? Well, B needs A done, C needs A done, H needs A done, so A has 3 tasks that follow it. So I'm going to put A up here, and it takes 1 minute, and that means then that requiring F to be done is E, so E can go down here. I'm going to make that a little bit neater. So E takes 1 minute. Now, since it's simpler and we can eliminate it straight away, the task that needs E done, or is preceded by E, is G. So we pop G in here, and we know that G also takes 1 minute. Now, let's have a look at these 3. In theory, there's a little bit of movement. The 2 that go here and the 2 that go here are interchangeable. They must come as a pair, but it doesn't really matter which way round they go. This one, however, requires A and is one of D's next steps. So B, and let's have a look at D. D needs G, H, I, and J. So which ones of those need A? So G needs E, so it's not that one. H needs A. So we're skipping from A, H, D. So we can pop H in here. H takes 5 minutes. Now we can do these next ones. Which ones require A, B, and C do? So I'm going to say B goes here and C goes here. Remembering, of course, to put in the numbers. So B has 1 and C has 7. Requiring B, down our list, we can see that J needs B. So there's J, giving us a 3. And requiring C is I, which has 4. And we can double check then, D needs G, H, I, and J. So that's us sorted. We now have the completed network diagram, all of the letters with their associated numbers. Progressing on to B, which is over the page, I've put it down here to make it a little simpler for us. John thinks that a team of mechanics would have the bike ready in 15 minutes. Determine if he's correct, he's working to justify your answer. Now, in order for the bike to be done in 15 minutes, that means that every job that can be done at the same time is done at the same time. So what we're looking for is the critical path. So if we have a look at the path as it moves through, the longest time at each path is going to be the time we're going to record. So if we look down here, F, E, G, so we've got 2 minutes down here, because we're going to have 2 minutes for F straight away. Now, A and H, A has to happen for each of these. So this first path, A, B, J, 1, 1, 3. So that's 5 to go this way. 1, 7, 4, that's 12 going this way. And 1, 5 takes 6 to go this way. So we have to take the longest path, because that's the critical one. So what we end up with is 2 plus 1 plus 7 plus 4 plus 2, which takes us, let's see, 2 plus 1 plus 7 plus 4 plus 2, and don't forget that last 2 for D. 3, 10, 14, 15, 16. So the fastest this job can be done is 16 minutes. So we can say no. 16 is greater than 15. And remember, the crocodile eats the bigger number. Oop. There we go. Question 11 was a pie chart. Now, this is where my recommendation that you always take a protractor into the exams comes in. You can be asked to draw a pie chart, and you won't be told before the exam that you need to draw one. Okay, so you should arrive equipped. Ruler, protractor, something to write with. Let's solve it. The survey is conducted into favorite pie fillings, and the results are shown below. 80 people like apple, 40 like cherry, 60 like lemon. Construct a pie chart to illustrate, and they give you a spare one on the back. So if you make a mistake, you can scratch it out and say, see the back. So to start with, we need to know the total. Our total is 80 plus 40 plus 60. So 40 and 60 make 100, plus 80 is 180. That means that each of our sections here is a fraction of 360 degrees. So from our total, we've got 80. Let's call this apple. For apple, we have 80 out of 360 multiplied by, 80 out of 180. I'm having a moment here, I apologize. 80 out of 180 people asked times 360 will give us our angle for apples. So cancelling this to make it a little easier on us, 8 out of 18 is 4/9, just halving both numbers there. So 4/9 of 360 gives us 360 divided by 9 times by 4. So divided by 9 is 40, times 4 is 160 degrees. Our cherry is 40 people out of 360, which again is 1/9 times 360. Oh, sorry. 40 out of 180. I'm having one of those days with this question. There's 2 out of 9, so 2/9 here. And so 2/9 of that gives us 40 times 2, since we know that 360 divided by 9 is 40, which gives us 80 degrees for cherry. And lemon, lemon is going to be our leftover. So our lemon is 60 over 360, 60 over 180. Times by 360, which is 1/3 of 360. So 1/3 of 360 is 120 degrees. We can double check that these all add up. So 80 and 120 is 200. 200 plus 160 is 360, giving us our total angle. So there's 2 of our 3 marks already, working all of that out. So if you didn't bring a protractor, you can still do this. I'm going to grab this digital protractor, line up my T-bar here, and spin it round so that my 0 line is on the line marked. On here, I can then mark on my 160, which, if I move my board down slightly, my 160 is here. And this is never terribly accurate on the board, so I do apologize. Here's my 160, and these lines should be drawn using a ruler. I can then rotate this round to my new starting line. And I can start at 0, and I'm going round 80 degrees this time. So 80 degrees this time, 10, 20, 30, 40, 50, 60, 80. There we are. And I can move my protractor out of the way, use the straight edge of a ruler or the bottom of my protractor to draw this line in. There's our pie chart, and now we can solve this, we can fill this all in. Here is 160 for apple. Here is 80 degrees for cherry. And our 120 degrees for lemon. Now, when we move on, we can now move on because we've finished that question. All right, now we have Laura. Laura sells smoothies. So, Laura makes and sells fruit smoothies. She plans to buy kiwi fruit in bulk. She considers the following 2 options. Option 1 is 35 kiwi fruit for £5.95. Option 2 is 45 kiwi fruit for £8.10. Determine which option offers the best value for money using working to justify your answer. What we need to do is find an equivalent quantity of kiwis that we can compare prices. So let's look at option 1 first. 35 kiwis is £5.95. Now, a factor of both 35 and 45 is 5. So if I say that 5 kiwis, I'm going to divide by 7 to get 5 kiwis in option 1. So 5.95 divided by 7, 5.95. There are 0 sevens in 5. So 56 is 8 fives, carry the 3, and that's 7 fives, giving us 87 pence for 5 kiwis. Okay. Option 2 is 45 kiwis for £8.10. So in order to get 5 kiwis this time, I have to divide by 9. So dividing £8.10 by 9, we get 0, 9, 0, telling us that 5 kiwis with option 2 costs 90 pence. So we can see there then that option 1 is cheaper, as 5 kiwis costs less. And we can see that our working there lets us compare these two sets of kiwis. Alternatively, you could multiply up to get much larger numbers, or you could multiply or divide by 35 or 45 to find the cost of 1 kiwi in each case, but you can just as easily compare 5 kiwis and get a nice neat answer for that. Now, question 13. Senior students are preparing to sell scented candles at the school fair. Before ordering the candles, they carry out a survey to find which scent people prefer. The results of the survey are shown below. Linen was 50%, vanilla 35%, rose 10%, and cinnamon 5%. The students sold 180 candles. They also sold in amongst that 65 vanilla. Was this more or less than expected? Well, they expected that 35% of their sales would be vanilla. So let's find out what 35% of 180 is. Now we can use our non-calculator percentage skills here. I'm going to do this in blue. So 35% of 180. 10% is 180 divided by 10, which is 18. 5% is half of that, 9. And 30% is our 10% times 3. Is 18 times 3. 3 eighths are 24. 3 ones are 3, plus 2 is 5. 54 candles. So they expected to sell 54. They really sold 65. So 65 is more than expected. And we have determined if this more or less, and we can say 65 is greater than 54 with our little comparison there. Now that ended the paper. That was all you were asked to do. If we jump back to our front cover here, we can see that on the front cover, I haven't included it here, but we had a total number of marks, and from there, each of these questions should have only taken 1.5 minutes per mark. So question 1 as a 2-mark question should only have taken you 3 minutes. Now go back through, have a look at the different questions, make sure you understand how to do all of the skills involved. Well, I've been Mr. Goan. This has been National 5 Applications Paper 1 2023. Look forward to my other videos. I'll be doing the Paper 2 soon. Thank you very much. Bye.